Hi everyone, I'm Crystal from IDERA, and I'd like to welcome you to this webinar titled Why Data Modeling is So Important for Data Mesh. Joining us today is Mike Ferguson, Managing Director of Intelligent Business Strategies Limited, and Jamie Knowles, Senior Product Manager for ER Studio. This webcast will be recorded, so you will be able to view it again if you'd like, and the recording will be available in the Resource Center on the idera.com website in a few days. If you have any questions, please feel free to ask them in the questions feature in the GoToWebinar control panel, and we will try to answer as many questions as possible at the end of the presentation. At this time, I will turn things over to Mike, and he can get started. Mike?
Thank you, Crystal. So good morning, good afternoon, good evening, everyone, wherever you may be. Thanks for taking time to come along to the session today. So let's talk a little bit about data modeling. I'm an independent analyst. I'm also chairman of Big Data London, which of course is a European show, largest data analytics conference in Europe. It runs next week, so it's going to be huge if you're going to be at it. I want to talk about what's data mesh and look at data products and the role of data modeling and data product development within a data mesh, and how you can reap the benefits of what I would call semantically linked data model components when it comes to data product consumption. So let's get going. Data mesh is about decentralization of data engineering to build data products. It's about, rather than it being done by a central IT resource of data engineers, it's really about getting more people in the organization to participate in building data engineering pipelines to produce data products that can be shared around your enterprise. And obviously in a governed way, so that those data products are shared in a compliant way, based upon the legal jurisdictions within which you operate. And so therefore, this isn't just an IT professional data engineering role, if you like. It's about multiple teams of data engineers around the enterprise, which could include IT expert data engineers embedded in those teams. But it's really a decentralized approach, and so therefore highly likely that we're going to have, if you like, citizen data engineers involved in this process. But clearly, if we're going to go do this, we have to coordinate it, and we have to get some kind of consistency going across the organization, and to be able to share things like metadata so that we can exchange data products and allow people access to them, irrespective of who produces them, as long as those people who need that data are authorized, of course, to access it. So one thing about data products, however, is there are a gazillion different definitions of this out there. So if you forgive me, I'm going to restrict my scope of data products, because I've read so many articles about people calling everything from AI bots to dashboards to reports to analytical applications as all data products. I would prefer not to do that. I prefer to think of data products as reusable data sets, but they're more than that, really. They have other things that are needed, like global identifiers. It could also be a virtual data product, that is to say, a virtual view of data that could be in multiple places, but looks like it's in one place and is accessed as if it was in one place. Or it could even be on demand, that is to say that there's a pipeline that's produced that will produce, that when you run it will produce the data product when you invoke it as a service. And so in that sense, it can still render, if you like, the data product in that regard. But all these other things like data, like reports and dashboards and machine learning models, these are things that are created using data from one or more data products. And obviously within the definition of data mesh, which was defined by a lady called Jean-Marc Degani, now very famous around the industry, formerly of ThoughtWorks, she described the data product as being more than just the data, that it's also the runtime specification, the pipeline that produces it, and an API which to access it, and describe these kind of characteristics, if you like, of data products. But I think it also has to have a context, because you can't share data if you don't know where its sovereignty is. And so to remain compliant with increasing amounts of legislation, especially in global businesses, we want to be able to share data, including cross-border data sharing, but still remain compliant with all of these new legislations. But probably the big difference between data products and the way we've been doing data engineering and analytical systems in the past is that we're not trying to build data for a single target system, like a data warehouse, or for a machine learning model, or for a graph database. What we're trying to do is build reusable data products that can be shared across multiple analytical workloads, whether or not those analytical workloads are running on the same data platform. By that I mean like a cloud database or lakehouse or something like that. Doesn't matter. The fact is that we're building these once, planning to reuse them everywhere. And so that's different from a classic kind of single system set of ETL pipelines. These are pipelines just to build data products, then we have to consume them and use them wherever we need them. And increasingly we've seen, as I spoke in the last webinar for IDERA, data fabric and data catalogs being used to, the software to be able to connect and understand the data sources and help build the pipelines to both produce the data products and potentially the pipelines to consume them, to construct the analytical systems and artifacts that we want to build. And there's a lot of questions who should build these. Clearly, data mesh is saying, well, it shouldn't just be centralized data engineers. It should be decentralized teams that can include citizen data engineers involved in that. And that opens up another debate about skills and upskilling folks around the enterprise to be able to do this. But I think the good reason, the reason is this bottleneck, and we need more people to get involved. Also, there's a discussion, where should all these data products be stored? Well, I think as long as they're published and governed, the sharing of them is governed in a consistent, robust manner, then I think it's not necessary that they're all physically in one place. But where does data modeling come into all of this? Well, fundamentally, data modeling is not an option. I mean, I've seen so many talks of technology over the last 12 to 18 months, and data modeling has just been skipped almost. This is a core competency, and it's always been a core competency in IT. But as we democratize data engineering out into the business units and upskill more people out there, it's absolutely a core competency out there too. So even if you're a citizen data engineer, or what some people are now calling analytics engineers, they have to be skilled in data modeling, which means understanding things like a data concept model, or analytical modeling techniques such as the two on screen here, like Data Vault, created by Dan Lindstedt, or Ralph Kimball's star schema, which is so widely used in the analytics world today. And both of these you will see in data warehousing and in data marts, as well as, of course, the traditional data modeling technique known as normalization, which has been around, since the 80s. But with data products, there are really, if you like, what I would call a kind of hierarchy to these to some extent. What I mean by that is, there are foundational data products, things that are fundamental in a business, customers, orders, products, suppliers, employees, shipments, returns, these kind of things are fundamental. And then other data products could potentially be built on them by combining foundational data products, for example, or filtering them, and then building up on top of that. But getting this foundation right is kind of really important. And there's basic ways even that you can do that, asking your organization to kind of just make an inventory of the types of master data in your business and the transaction types within your business. That gets you going. I mean, if you look at insurance on the left, banking on the right, just some examples of master data entities and transaction types within those vertical industries. And the reason I've done that is because each of those, if you like, entities, if you like, or master data entities or transaction types, could easily become a foundational data product. But one of the other quick ways of doing this is to build a data concept model, to understand what are the data concepts within your business that you can then use, and each one of those can then be used to create a data product. So right off the, right out of the starting blocks, you can see why data modeling is important to building data products in the data mesh. Because if I can build a data concept model and work with a business to do that, I can understand what are the core sort of data entities, if you like, within our organization. And not only that, but I can see the relationships there. But there's no detail at all behind this. It's not a logical data model. It's just a data concept model. But nevertheless, being able to do this is fundamentally important to quick starting the building of data products. Now there's help out there. Sort of we see sites like schema.org or Microsoft's common data model, which has been pushed out onto GitHub for anyone to use. As quick start mechanisms predefined, if you like, that you can pick stuff out of there to get you going. But nevertheless, there's got to be some technique to go around building data products, and we need common terms for that. We need a data model for a data product. We then need to obviously be able to discover and map, discover where's the source data for this data product, and can I map the physical names of various source systems to the common terms that would describe a data product. And then I can profile the quality of the data in the sources, and if necessary, clean up and integrate any data to provision a data product and publish it and make it available for use. So if I was to start with that, from a data concept model, I can then quick start a business glossary, say, well, for each of these concepts, put that in a business glossary, which these days is typically held in a data catalog. And then from there, I can get the business involved in building out the attributes that would describe those particular data concepts or those data products. So I can get subject matter experts involved from around the organization, perhaps who best understand what a customer is, and so they can then get involved in describing and completing the description around that. Similarly, for people who understand product data and work with it every day, they can do the same for that, or people describing orders in a similar way. But therefore, the data products that we produce in a data mesh should be described using business terms as data names, so that they're meaningful to the business. People can understand them, and they can look up those descriptions and terms in their business glossary, just in case they're not sure of the meaning. And once you've got a description of your data products, obviously you can share that metadata with a whole bunch of other tools, including data modeling. And so therefore, by giving access to that metadata within the data modeling tool, or indeed an automation tool, and indeed any of the others that you see around here, you get the ability to hold, for example, data modelers accountable to use meaningful business data names when they describe the schema of a data product, rather than invent physical names out of their head. And which brings us to data modeling with respect to data products. If we have the terminology to describe a data product from a glossary, bringing that into a data modeling tool then allows us to describe a schema for each of the data products that you want to create. And so next question is going to be, well, what should that schema be like? I mean, should it be a data vault? Should it be normalized? Should it be Kimball? Should it be Dean? How should that be? Well, let's look at that. Well, if I take the technique that's been around the longest, normalization, since Dr. Ted Codd's day, who of course invented this, then what you see here is that there are representations of data entities, students in this case, or courses that I've kind of surrounded with a red box. These are like data model components, but they're describing an entity. It's normalized in this case. And there are relationships also represented in this data model through the other entities that I haven't drawn red boxes around. But leave those aside for a second. If you take the idea here, it's normalized, and there are benefits and disadvantages to the normalized approach. The advantages is there's no data redundancy. There's no piece of data that's represented more than once. It's a neutral design. It's been in data modeling, since the 80s, over 40 years of data modeling with this kind of technique. And it's good if you're going to update this data, or you want to create a data product that's going to be updated a lot. A master data product, for example, which may be stored in an MDM system, you might want to think about that. The disadvantages, of course, if you were to sort of have a data product in a normalized data model form, is that if you want to use it for analytics, then I've got to transform it into some kind of analytical data modeling technique that I'm going to use in my warehouse or my data marts, for example, to move it from normalized to Kimball or normalized to Data Vault. But this is one approach. More appropriate perhaps for master data products. Another approach is to look at Data Vault. I'm not sure if you're familiar with Data Vault or not, but it's been around quite a long time now, not as long as the one on the right, which is Kimball, but nevertheless, Data Vault is about breaking each data entity apart into, and you can see here, a hub, links, and satellites, and the combination of those are representing what I would call a schema component, or that schema component is effectively like a data product. In this case, representing manufacturing plant. Similarly, on the right-hand side, you could argue that a dimension such as customer, or a fact such as sales, represents a data product in the sense that sales represents the sales data product, customer represents a customer data product. In that case, they're denormalized. So then it goes, well, what about these as techniques for data modeling? Well, the advantages to the Data Vault approach is that it's already normalized, but it means that the data products that you created, if you were to store them like this, would be data warehouse ready. Data Vault is a data modeling technique for data warehouses, not a data modeling technique for anything else other than that, not for data marts or anything like that. But it's very easy to change. There's a whole beauty of Data Vault as a modeling technique, very rapid to be able to change with minimum impact on anything else. The disadvantage is obviously, unlike master data, which can be used for both analytics and transaction processing systems, this kind of modeling technique is optimized for analytics. And you would need to denormalize that if you wanted to consume it within a data mart. But nevertheless, it's a valid modeling technique. If you were to choose the other one, which is Kimball, in order to take a model component, if you like, again, that technique widely used in data warehousing and data marts, and so it's, if you like, ready to be picked up and used within any one of those environments. It's very easy to understand because it's denormalized. Often, so you see a denormalized dimension, and so it makes it pretty rapid and easy to assemble data products to create a star schema. But again, only for analytical use, and probably not the kind of modeling technique that you would use necessarily for a master data product. Once you've got a schema for a data model, if you like, for a data product, then of course you can then discover where's the data that I need for it. Can I map the physical data that I find to the common terms that describe the data product? Can I profile the source data to make sure that that the data is in good shape in those source systems? And if not, then we can clean it up and integrate it. Now, in the past, I think I've mentioned this in the last IDERA webinar that we did, but obviously data catalogs are what we're using these days to automatically discover data in source systems, help us do that job more rapidly, understand the physical data names of all the data that's out there. And then obviously data catalogs are also capable of mapping from physical data names in the disparate systems that you discover to common business terms that can be described in a business glossary. And we already said that data product data names can be described as business terms in a business glossary. And so a data catalog that supports automatic discovery and mapping to a business glossary can therefore not only to find out the physical data names of what data is known by in your source systems, but can then map those physical data names to common business-friendly terms in your glossary associated with each of the data products, which then allows you to know not only what the data product is, the terms describing it, the schema that we've already talked about, knowing where the sources are and knowing what the mappings are, and then it makes it relatively mechanical to figure out how to produce this thing. So as you can then clean up and integrate that data, and for each of the data products that you've designed in data modeling, you can build a pipeline to produce that data product that can be published and shared in a marketplace. And I think last time out I talked about how data automation can plug into data modeling and help automate or generate the pipelines needed to produce those data products. But the key point here is that data modeling is fundamentally involved in the construction of data products. Now, what about semantically linked data products or on data model components? What do we mean by that? Well, when we publish a data product and want to provision it, make it available for sharing, the one thing we want to be able to do is give consumers the confidence to know that they can just pick these things up and run with them. And that if they pick any combination of those things up, then they know that they're going to work together. And that really means that when you build a data product, that there are certain things that you really have to consider almost sacrosanct, and in order to be able to make them almost as easy to use. And one of the things is global identifiers, and very much something that you want to create for a data product, because it therefore allows identifiers to be reused or even referenced. But the whole purpose of data products is to create, if you like, ready-made. It's like going into a canteen, as you see here, and you pick whatever you need and consume it. And you don't go into a canteen at lunchtime and you want to eat chicken, and somebody gives you a raw chicken and a few raw vegetables and say, you figure it out. What you're looking for is ready-made, and you want to pick whatever combination and know that it's going to work for whatever analytical project that you have, whether that's to do with a data mart, a data warehouse, graph database, machine learning model that you're building. You want to know they're going to work together. And that's why when we define both the terms used by data products, and also when we create the data model for each of the data products, we need global identifiers. So for example, here you can see customers, product, and orders. Well, obviously orders would like to reuse the keys of the other two, so that if you pick up orders, it references customers, it references products. So therefore, if you picked up product, customer, and orders and say, I want to consume all three of these for my analytical project, you know they're going to work together. They should snap together like Lego bricks. And so the idea is that a consumer can just take these and almost assemble a bigger data model to describe a data mart or to describe a data warehouse or to represent those as nodes and edges within the context of a graph database. And so you should have the confidence to be able to do that, which is why data modeling is so important, and it's why things like keys are so important. In this case, global identifiers matter as a to make sure that no matter who's producing these data products around the enterprise, there are some things, some best practices that they need to adopt to make maximum ability for people to just pick the ones they want and assemble them quickly to construct something bigger. In this case, a data mart or a data warehouse, for example, where I can say, well, I need customers and products and orders, and returns in my data warehouse. So I should be able to go pick those that are ready made and just assemble them in my data warehouse to get going much more rapidly. So here's an example. The idea that I build these data products to describe particular data entities, as we saw earlier: customers, products, sales, channels, time, shipments, returns, distribution centers, for example. And you want to then construct a data mart that looks at who's buying what, through, where, when. So you should be able to just pick the data products that you need and just assemble them. And the fact that they're using global identifiers, it should just work. So you may have to do, if you've stored these foundational data products in say data vault format, you may have to denormalize them to actually put them in a data mart using a Kimball approach. But nevertheless, the point being is that they are almost like just building blocks that we can quickly assemble them and make use of them. And once again, if I want to, I can, as I said in the previous IDERA webinar, we can even use automation to build those pipelines that select the data products that you want and automatically construct what you're trying to create. So what we're really saying, therefore, is that data modeling is fundamental. It's really about the people who are tasked with constructing data products in a data mesh need to be able to, first of all, participate in constructing a data concept model. Or even if they don't do that, even if they just make a list of master data entities and transaction types, and then say, well, we need to create a data product from each of these, you still need data modeling techniques to be able to go and do that, and to be able to understand, well, how do we get to a normalized representation or a data vault representation? But rather than building an enormous data model of a single destination system, like building a data model for a whole warehouse, we're not. What we're building is just the model of a data product, which effectively is like a building block that I can then pick and choose to put together for different kinds of analytical workloads that are downstream. So building these data products allows us to then get going quicker in constructing downstream analytical systems, because we're producing data that's described in common business terms already. It's got a schema for that particular data product, and it's got global identifiers so that I know that when I construct my model for a bigger system downstream from there, that what we're actually going to get is an assembly of these data products where all the keys already work and everything's already in business terms. So it's already business friendly. And we don't have to build some other semantic layer on top of it to just make it understandable by business, because the terms we're already using are business terms. So this is a bit like, if you think about this, a bit like, people could build cars when we started building cars, but then Henry Ford came along. And what did he do? What he did was industrialized it. He built a production line. And he said, okay, we're going to standardize a few things and we're going to make it faster to build. And that's exactly what's going on here. Standardize a few things, make it faster to build. Build these components so that as they move down the line, then other people can just pick those components as reusable data products, snap them together and go. And so what we're attempting to do here is shorten the time to value, make it faster to do, plus get more people involved in doing it. So that is to say, if we train up all the people around the organization to have data modeling skills, then they are far more in a position to build data products. And if we have a data concept model, everybody can relate to that and kind of see, well, who's building these ones and who's building those ones. So that essentially what you're doing is creating a whole bunch of reusable components that can be snapped together in whatever combination you like further down a production line to suit the analytical use case that you want. And that you're not always tasked with start again, build a data model from scratch, go all the way back to the sources, figure out how everything comes together and build it all as a single silo. That's what we're trying to get away from. What we're trying to do is say, no, don't do that. Build these reusable components called data products, which have their own data model, but that can be assembled with other data products to rapidly construct analytical systems, or just the data I need for my feature store to support 3 or 4 different data science projects. So that's what we're trying to do here. It's like a jigsaw puzzle. It's which pieces they're out there. Which pieces have been built, and then how do you assemble them to create the bigger picture? So I'm running a little bit ahead of time here, but if I conclude then, data mesh is growing in popularity. Frankly, whether you are bought into data mesh as a concept or not, I would still think about data products, because data mesh popularized the concept of data products. But whether data mesh came along or some other name, it's still a good idea. And I don't think the idea of data products is going away. And on that basis, I think data modeling is therefore got to become a core competency if you're expecting teams around the enterprise to produce these rather than rely on centralized IT. It's not that centralized IT don't know what they're doing. Of course they do. The problem is not enough of them. And they're a finite resource, and they've become, through no fault of their own, they become a bottleneck. Just can't keep pace with the demand now that it's coming across from everywhere. And so as a result of that, it makes sense from a corporate perspective to upskill other people and get more people being able to do this, as long as it's coordinated. As long as we say, okay, we want to put a production line in place here. So, we need some, if you like, rules to be followed. But the idea is that we can create these consumable, reusable data products where people can combine them to create data models that are optimized for various kinds of analytical workloads. and the fact that the consumer knows that this is going to work because of the fact that we've got things like global identifiers in place. And obviously, the more data products that you build up over time, then the faster it comes to be able to assemble things down the line, because more and more of what they need of those consumers is already made. And Data Vault allows you, to deconstruct a data entity, keep it normalized. It's very easy to change. So if you come up with a new version of a data product, because someone said, "Oh, I forgot to put that in, I've got to put this in," then clearly Data Vault would do that. There's been several presentations I've already attended at various conferences this year of companies already using Data Vault as a modeling technique for data products. Data warehouse development becomes far more rapid because I'm just picking things that I know are going to work together in an analytical environment and assemble them to get me going more rapidly. And therefore, if I look at it, making sure that this becomes a core competency is really not something that we're just saying everybody has to have. It's there for a reason, and the reason it's there is so that we can accelerate the build, so that we can get to the point where it becomes progressively more rapid to consume and do other things on the back of more and more data products as they become available. And that's a good thing, because obviously shortening time to value helps you become more competitive and make decisions faster. So with that, I'll hand back to Crystal and say thank you very much.
Thank you, Mike. Now we're going to go over to Jamie Knowles, who will show us a brief overview of ER Studio and how it can help with data modeling. Jamie, over to you.
Thanks, Crystal, and thanks, Mike. So I'm going to try sharing my screen. Can you see my screen already? And if so, what can you see?
We can see your screen, your slides, product development, and a data mesh.
Beautiful. That's great. Right, we're good to go then. Hi, everybody. I'm Jamie. I'm the product manager for ER Studio. So I'm going to talk a little bit about the data factory that Mike was talking about. So we've got a number of products within IDERA. The two products I really want to talk about today are ER Studio and Warescape. So ER Studio is a data modeling tool. Warescape's a tool for automating the creation of a data warehouse and its pipelines. And I'll talk about how these fit in. So the mission, as Mike was saying, this data factory or data supply chain is what we really want to try and achieve, and some of the sort of components in there. So Mike was talking about the different domains of the organization that are going to be responsible for different data products. We've got a whole bunch of different people, subject matter experts, etc., all working together. We want to provide tools and automations that support those people and give us that sort of end-to-end, well-automated, efficient data supply chain. We want a data storefront where people can browse for information. So we were talking about the restaurants. Hey, I want to see what we got in our canteen. Show me some menus. I'm really interested in chicken today. Where's chicken? So the storefront's a really important part of it. And throughout, it's absolutely vital, is some sort of governance framework. We want to make sure that the right data gets in the hands of the right people and not the converse. So make sure our data is well protected. Now, some of the challenges that we're going to try and address with our data factory are here. So consistency is really important. So Mike was talking a lot about that. We want a business-friendly mechanism for those domain staff. Now, quite often they're going to be non-technical sort of people. those subject matter experts. So we might get our HR department contributing to the design of HR data products. So we need a mechanism for them to be able to collaborate and design these data products. We need to understand where we're going to get all our data from. So we're going to have a whole pile of data sources which we need to understand and see how they can be used to deliver these data products. We need to be able to publish documentation to our data storefront, provide those menus. And then there's the delivery mechanism. So how will that factory or data supply chain work to deliver all this? So there's some of the challenges that we've got. So let's see how we're going to address them. So this is where ER Studio comes in. This is the sort of initial design stage of the process. So there's various inputs and jobs that we've got to be able to do. So at the top, Mike was talking about these common concepts, common definitions. So what are the important pieces of information that we might want in our restaurant to provide on the menu? So we might be looking at sort of master data entities and transaction types of the organization. The next thing is the data sources down at the bottom. Where are we going to get data from? So let's produce a catalog of those data sources and understand them all. And then we've got the requirements for products. So what products do we want to provide in our factory? And throughout, we've got a data catalog. Now, ER Studio has got a built-in data catalog. We've got a business glossary where data stewards can be working on business terms. Against those business terms, they can be specifying some of the policies of information. So a particular business term, we might give it sort of classifier flags like, is it personally identifiable? Is it sensitive? What policies do we want to apply to that? As we go through and start creating our catalog of data sources, we can map them to those business terms and create our data catalog. Likewise, with our understanding of the common definitions, we can start to connect those to the business glossary. So the language is aligned with the language of the business. We understand, again, policies and rules around the data. And then when we're designing our products, then we can also attach that to these models. Now, the output of all this is going to be well-designed products, so a series of product designs, and also a big old list of our data sources, all nicely documented, nicely classified in our data catalog. So that's the primary output of ER Studio. Now, in practice, it's all going to be driven by models. Now, this is quite a scary old diagram, but sort of running through it. Now, as Mike was saying, the sort of approach that we've taken in the past to designing traditional data assets, whether it be a relational database or a JSON file, we can use the same sort of approach for data mesh product design. Now, in a traditional data modeling world, we might have a number of parts. We might have some sort of common enterprise data model or group of data models. In this diagram, we've got a nice enterprise conceptual model. So we might have small number of key concepts, and there's not a lot of detail around them. It's just a list of concepts with rough relationships between them, a bit of a description of each one. We then might need to abstract that. So we might find that customer, for instance, hey, we've got a number of different types of customers. Let's understand those. What are the really important attributes of some of these concepts? And then there's the how do we identify these concepts? So everyone, and as Mike was saying, these global identifiers are absolutely vital. So a traditional enterprise model will contain all of that information, and what sort of relationships are there between these concepts? Now, a lot of people say, hey, an enterprise data model is going to take us a lot of time and a lot of effort to build. It doesn't have to be. So this could be really just focusing on those core master data entities and transaction types and a fairly small and manageable model. But the main thing is it then forms us this palette of common concepts that we can use in our data mesh product design. The enterprise models will generally be connected to our business glossary. So again, we can check up that the naming and the language is common and well understood. The definitions, so something like credit rating score. Now that could have many different meanings and calculations. So we're standardizing on this. Everybody understands what all this stuff means. Now, traditionally in the past, if we're designing an application database, we might create a brand new blank model and then look at our common palette of entities and say, hey, which of these do we want to put into our newly designed application database? So we can drag from this palette, create a nice logical model of that application database, and then generate a physical model using any technical language and naming conventions that we want, and create a model that's specific to the implementation, whether it's SQL Server or JSON or whatever. We can use the same sort of process for data mesh product design. So whether the data mesh products will be delivered through some sort of streaming system as JSON files, or they're going to live as data sets in the data warehouse, we can use the same sort of approach, bringing in from the common palette, creating logical models that are easy to understand by business people, so those subject matter experts, and then the tool will then help us then generate technical schemas for our databases that we can then actually implement. And we can create a nice catalog of these data mesh products that everybody can view. Everything's connected to our business glossary, and this really sort of helps us provide that menu for our restaurant. So if I'm looking for, hey, show me which data products contain chicken or credit rating score, then I can see through the tool where are all these where are the products. And if there aren't, then I've got a nice mechanism to help me design new products. So that's how ER Studio can really help. Now, once we've done our designs, then we want to start delivering. And this is where Warescape comes in. So ER Studio can provide product designs and can provide really nicely marked up models of all of our data sources with classifications. Now, those classifications can come from our business terms and the data catalog. ER Studio will work with tools like Calibra. This is where it gets really exciting. So we could have our data stewards working in Calibra providing policies around data. ER Studio will pull all of that useful knowledge, that useful markup, and give Warescape nicely classified and documented data sources. Now, Warescape then comes along with automation policies, and the data warehouse architects combined with these policies can then create designs for warehouse structures. So all of those data products that are going to exist as data sets in the warehouse can then be nicely delivered as designs. Now, Warescape will then actually design and then implement the structure of the warehouse and all its pipelines and execution schedules, and then provide all the documentation and lineage on top. So in summary, we want to produce a well-governed data supply chain. So I've used the word data fabric. This is really the tools working together. So ER Studio, Warescape working together. So we've got good integrations between them, which allows all of the different people to be able to work together. Data mesh allows us to design well thought through products and get the right people working together on them. And then the models are really going to sort of support all of this. So we've got our common data models that Mike was talking about. We've got our data catalog that tells us where is data. I want to shop for data. Our data storefront gives us a mechanism for our business stakeholders and subject matter experts to be able to design the requirements for those data products. And then governance is baked in. Whenever we're producing models, we can connect to our business terms, see what the policies are, and Warescape will actually deliver security policies in the warehouse based on those requirements. And as we're going along, everything is documented. Good. So that's really all I wanted to talk about. Let's go to questions.
Thanks, Jamie. We do have a couple of questions. I believe these are general questions about the data modeling and data mesh. Mike may want to answer these. Let's see, the first question is, can we safely assume that the business concept glossary, business names, catalog are readily available for data modeling prior to the start of data modeling?
Question. Mike, do you want to take a shot at that, or shall I?
Sorry, could you repeat the question again? Sorry.
Sure,
So
no
the question
problem.
was, oh, go on, Crystal.
Can we safely assume that the business concept glossary, business names, and catalog are readily available for data modeling prior to the start of data modeling?
No, the whole idea here is not to define the entire business glossary before you start everything. I mean, the whole idea is about moving towards incremental build by creating components. So You don't have to define every single data concept in the enterprise in order to start building and designing, doing data modeling. But what you really want is to have a methodology that allows you to define the data entities with common business terms, and to then use that within data modeling. So with respect to other technologies, well, then clearly it depends on what technologies you already have. I mean, Jamie talked about integration between ER Studio and other catalogs, like he mentioned Calibra. So without knowing what technologies you necessarily have, so you might say, well, do we have to have a business glossary in place in order to build a data product? Do you have to have business term definitions in place before building a data product? I would hope you have, because if you don't do that, then a data modeler is going to just invent data names out of their head. I mean, I've done lots of data modeling in my career, and people do. They create their own data names. Yes, they talk to the business, but what we're talking about here is where the business decides the business terminology and the data model is using it. So I would want to make sure that the terms associated with data product are upstream of data modeling. If you try and retrofit this, it's going to be far harder. So I'm not saying that data modeling can exist without business glossaries. Of course it can, but we've been doing that for years. But look what we've got. Look what we've got. If you look across the distributed data landscape in most enterprises today, there are a gazillion physical data names for the same thing, created by different data modelers, not inadvertently to create a mess, but that's what's happened. And a lot of them use all kinds of physical abbreviations that a business user has no idea what they mean. What we're trying to be able to do is industrialize this. And I really mean that. I mean, we really want to make this run like a well-oiled machine, to really speed up our ability to build quicker. And if we're going to do that, it can't be a case of business not involved and data modeling just gets involved first. We've got to have it together. And I really believe, therefore, that yes, business terms for a particular data product, not every data product, not every data concept, but for the ones that we're going to build, you do need to come up with business terms for those so that you can describe them and have that meaningful metadata available to consumers to understand what the data means.
Would it be safe to say that sort of previous projects like a master data management project or even enterprise data modeling projects, integration projects where you've already got an enterprise data model and a business glossary, is that going to be useful to kickstart a data mesh project?
Absolutely, yes, of course it is. I mean, obviously every organization has got an investment in the past, and so making an inventory of what you have in terms of, I mean, that's the reason I included transaction types and master data entities. If you've already got definitions of these already in place, potentially it's an okay place to start. But certainly in terms of business data definitions, very clearly, we're trying to get business to decide those in order, otherwise, that we will forever be building semantic layers to hide all of the names that IT professionals create. And so we're just trying to get away from it by creating a production line that involves business and IT from the get-go. But obviously making looking at what you've already got is obviously worthwhile. And if there's a huge reliance in your organization already on an enterprise data model, then clearly I would assume an enterprise data model has been built in partnership with the business in order to get meaningful definitions of data that you want to create.
Thanks, Mike. Our next question is, can you please explain self-entity model?
Self-entity model. I
was wondering about that. Was that a term you used earlier on, Mike? Self-entity?
No, I hope not. Self-entity. Self-entity. No, just
not sure about that.
Hunting back through my slides, I don't think I mentioned self-entity model.
Yeah, no problem. We'll move on because I can't remember that one either.
All right, while Mike is looking for that, the next question is, from what I understand, taking the approach on building a data warehouse on data products would mean moving the complex source system to DW, data warehouse staging, pipeline ETL jobs to source systems to data products environment, and making data warehouse pipelines or ETL jobs simpler. Is that correct?
Okay. That was quite a lot. Could we say this again, please?
Sure. We'll break it down since it is a more complex question. So they're saying that their understanding is that you would take the complex source system to data warehouse staging, and the ETL jobs would move to source systems to data products environment, and that would make the data warehouse pipeline simpler. Is that correct?
Oh, I see. Potentially, yes, because the data warehouse pipelines effectively would be consuming ready-made data products. So therefore, data is already integrated. Like, for example, if it's customer data, the data has already been cleaned and integrated and available as a customer data product. So you don't have to do that within your data warehouse. And so, I mean, the big difference here is, rather than with a data warehouse, or let's say many of my clients have got multiple data warehouses. So, rather than building ETL pipelines for one data warehouse and build them again for another, even if the same data is being used, I mean, customer data being used in both warehouses, build the pipelines again in many cases if it's done on a different system. I've seen that within organizations. To try and get away from reinventing when you're building pipelines for single systems, sort of this siloed approach to point-to-point data engineering. We're trying to get away from that and say, can we build these once, reuse them everywhere? And also, can you accommodate change? Because obviously everything changes over time, but very clearly, can you build them once and reuse them everywhere? Because it seems every single time we come up with a new analytical system, we're forcing people to go all the way back to the sources again and build again. And so what we're saying is, look, I mean, surely there's a way to speed this up by creating reusable data products that allow us to, if you like, stand on the shoulders of people who've gone before us and make use of what's already made. So yes, in a way, it would simplify actual data warehouse construction, because in a similar way to master data management, because master data management often, was put in after data warehouses were built in many of my clients. But what it's done is it ended up with, complex data engineering to build supplier data, or to build employers data, or customers data in an MDM system. That happened before the warehouse, and then data warehouses now take their data from the MDM system. And so and so simplified data warehouse ETL processing as a result of that, because the data that they're taking was already clean, already integrated. And that's exactly what we're trying to do here. But obviously, the purpose is to not only do it to speed up data warehousing and simplify that process, but also to speed up development of machine learning models, to speed up the development of data marts, to speed up the development of graph databases. You know, there's more analytical data stores out there than just data warehouses and data marts. And so what we're trying to do is effectively save people time.
Thanks, Mike. Well, everyone, we are all out of time for today. We'd like to thank you so much for joining. I would also like to thank Mike and Jamie for their presentations. I know that we have a few questions that we weren't able to get to during the call, so we will reach out to you individually to get you the answers to your questions that you have. If you would like to learn more about ER Studio, please visit the ER Studio pages on IDERA.com. You can get a 14-day free trial, request a demo, or request a quote. We again appreciate you for attending today, and we hope to see you again on our future online events. Thank you.